Okay, so the mass is 63 here. So what this means is this is an isotope of nickel. It's not the one on the periodic table, which remember is just a average. So protons and electrons is equal to 28 and 28 here. Remember, this is a neutral atom, so there's no charge on it. So the electrons and protons just equals the atomic number. The neutrons, remember, is just that, which happens to work out to 35. So that's the answer to that one. Then we have A, which is a little different. So we got 5927, cobalt 3+. Protons, neutrons, and electrons. Always find it on the periodic table first. So we're looking for cobalt, which would be sometimes they're a little tricky. Oh, it's right next to each, right here. And I guess you can figure out from one of these numbers. So it's atom or element number 27. So we know the number of protons, right? Now here's where it changes a little bit. The electrons are different for this compound. So it's 3+. That means there's less of a negative charge, or 3 electrical charges worth of electrons, or in total 24 electrons, right? So if it was 27, it would be neutral, but since it's lost 3 of them, it becomes 3+, right? If it was 3-, the number of electrons would be 30. It'd be 30, or 27 plus 3 electrons, right? So if you have a higher negative charge, that means you have more electrons, each one worth 1 charge. Same with the protons. But remember, you can't change protons around, you could only change electrons around. Then, the neutrons is the same thing. You can't change the number. Well, you can actually. The only thing you can't change is protons. So you do this, and you would be ending up with 32. So there are 32 neutrons, 27 protons, and 24 electrons in this question. Next, we would go to question 14. Name the following compounds. So SN3, PO4, 2. So let's look at this one first. Once again, you go down these naming parts here, and we start with SN. Remember, it's always the first element first, so we look at it for SN, and we can see that we have SN2+, or SN4+. So how do we know which one to use? Well, we look at the substituent on the opposite side. Remember, they cross over, so that means it's SN plus 2, or 2+, plus PO4, 3-. And we can find PO4 in this one here. So you can see that the phosphate has a 3- charge. So this compound happens to be, where's SN? Tin 2, right? We discovered that the positive, or the cation, is tin 2, and the end part is the phosphate. So tin 2 phosphate is the name of that compound. Now we go up here. What's the next one? NO2. Same thing. We look down here. You'll notice that there is no nitrogen here. But remember, for most things it just starts, the cation